It looks like the set of a sci-fi film, an apocalyptic vision of life in 2050 after it all goes wrong. And yet far above this dank underground world sits a little slice of paradise. It's mid-afternoon in the village of Abdelaziz, just outside Malaga in Spain. Siesta time. As the villagers sleep, in the valley below, an army of 21st century engineering stormtroopers are advancing into battle. These men are on a mission. They're heading to a place no one has ever been before. Temperatures will reach well over 50 degrees Celsius. Working conditions will be among the most difficult on Earth. They're heading for the heart of a mountain to meet a monster. And here it is. This is one small part of one of the largest land vehicles ever built. The front section of a tunnel boring machine, or TBM. And if you're planning to drive a hole right through a mountain, you shouldn't leave home without one. So, how do you cut right through a mountain of rock? How do they do it? In the Abdelaziz Mountains, they're building two parallel 7-kilometer railway tunnels to expand Spain's high-speed rail network. It's a testing challenge for both man and machine, working far beneath the mountain peaks where the temperature at the cutting face can reach astonishing levels.
Right now we have a temperature of about 40 degrees Celsius, but when the machine is working, it can rise up to 100 degrees Celsius, and it's not nice to be in here.
The engineers aren't the only people digging deep. This project will cost more than $140 million once complete. The traditional way of building tunnels is to blast them out with explosives. The new way involves building the largest and most expensive land vehicles in the world. These TBMs are built by the Robbins Company and Mitsubishi in Spain. And if you fancy buying one, it'll set you back a cool $20 million. But you may need a bigger tool shed. Each of these giants weighs a staggering 1,500 tons and is longer than a football pitch. It takes hundreds of thousands of precision parts to build a TBM. The technology is literally cutting edge. At the business end of a TBM, 64 reinforced steel blades cut tunnels of up to 10 meters in diameter through the hardest rock. Of course, the trouble with a vehicle this long is it's lousy at turning corners. So once built, it's taken to pieces again and transported by road to the construction site on 30 trucks. Once there, it takes 4 months to reassemble, and then off it goes into the mountain. Every 24 hours, they cut approximately 30 meters further into the mountain at a working speed of 2.4 mph. That's not miles per hour, it's meters. The TBM is like a massive spinning top with giant metal teeth, slowly grinding and chewing a path through the mountain.
We are right now in the cutter head, in the farthest part of the TBM machine. It's the closest one to the rock. And here you can see we have 64 cutters. They goes all around the machine.
The cutters can grind through the hardest of rock. It's the soft stuff that causes the problems.
It's very soft and it sticks really to the cutter head like concrete.
The cutter heads themselves can be clogged up or ripped off, and the TBM grinds to a halt. The TBM can't return to the surface. It's too big. It would take too long and cost too much. So how do they mend this monster many kilometers below ground? Despite all the state-of-the-art machinery here, there's no substitute for a power drill, a few hammers, and a bit of honest muscle. The TBM controller himself takes charge. Using thick gloves and a length of steel chain, he carefully removes the damaged 125-kilogram cutter head and winches the replacement head slowly into position. Then, gently, and precisely, he maneuvers the cut-ahead into its cradle. Now the TBM can resume its journey through the mountain. As the TBM moves deeper underground, the safety of the workers is paramount. Tunnel building is the most hazardous type of construction, and the biggest danger is that the roof of the newly excavated tunnel towards the front of the TBM will collapse. It's said that in the first half of the 20th century, tunneling claimed a life for every kilometer of excavation. So, how do they guard against tunnel collapse at the head of the TBM? The answer lies with these prefabricated blocks of concrete. Outside the tunnel are thousands of these blocks, each one weighing 11.5 tons. As the TBM advances, it leaves a gap. When the gap reaches 1.5 meters, it's immediately filled in by a ring of these blocks. Just getting them into position is a risky business. These massive blocks can easily cause serious injury or death. So, in the confined space, the blocks are carefully picked up by suction and moved to the correct angle before they're pushed into place. Then they're bolted into position. When a complete ring is formed using 7 blocks, the TBM can advance further into the mountainside, its workers confident that they're fully protected from a tunnel collapse. Up above in sleepy Abdallahis, the villagers are settling down for the evening meal. Paella perhaps, and a little wine. But for the workers down below, the pace is relentless, servicing the TBM monster which never sleeps. For the next 2 years, 24 hours a day, 7 days a week, they'll be burrowing through this mountain, building the magnificent high-speed rail link, bringing the people of Abdallahis closer to Madrid and the world.